Merry Christmas, everybody. Hope you guys are enjoying a great December. Santa Claus is hopefully coming to town your way soon, but right now he's bringing us integer exponents and scientific notation for section 4.1. I'm Mr. West. Let's go ahead and get started. Here we're talking about exponents. Now, exponents is just an extension of what addition and multiplication started. So as we know that 2 plus 2 plus 2 equals 6. An easier way to write that problem is 2 times 3. Okay, so that's what multiplication does. Multiplication is just repeated addition. Okay, now if we want to do something like 2 times 2 times 2, that's 2 times 2 is 4, times 2 is 8. An easier way to write that is 2 to the third power. We can use exponents. So it's repeated multiplication. Exponents, repeated multiplication. Repeated multiplication. Okay, now 2 to the fifth power, what is that equivalent to? It is equivalent to 2 times 2 times 2 times 2 times 2, or I think that's 32. 2 is the base, and 5 is the exponent. Whatever the base is, you multiply it times itself. That's the key part of exponents. You multiply it times itself 5 times. Okay? Whatever the exponent says, that's how many times you repeat the multiplication. So here is, let's say number of times, not how many times. Number of times you multiply base by itself. I wish I could have said that without saying you, but too late. Now, that's fairly straightforward. If we do some examples, we're going to get to see what it's all about. And we're actually going to kind of extend off of this. Now, if you want more basic exponents, I'm going to recommend that you check out some of my other videos for Algebra 1. But this is going to be a video basically with the understanding that you've had some experience with exponents. Now, we already know that. Let's get a highlighter out here. Let's go green. That 2 to the fifth power, we've seen that above. That's 2 times itself 5 times. 2 times 2 times 2 times 2 times 2, okay? Now, if we're multiplying this by 2 to the third power, we're going to have to change the color here. 2 to the third power, that's 2 times 2 times 2. Okay, all in all, how many times are we multiplying 2 by itself? Well, we have 1, 2, 3, 4, 5, 6, 7, 8 times. So if we wanted to, we could multiply this all together, and we get 2 to the 8th power. That would be a simpler way to write that. But we can also simplify it. We know this is 32, times 2 is going to be 64, times 2 is 128, right, 128, and then times 2 is going to be 256. So 2 different ways to think about how to do those exponents. Now, what did you notice? Well, how did this 5 and 3 correspond to our new answer of 8? Okay, think about that. 2 to the fifth times 2 to the third, we got 2 to the 8th power. How does that 5 and 3 relate to 8? Well, the relation is, if we have a base A, and we're multiplying it by the same base, these bases need to be the same. Bases must be equal. What we do is we add the exponents. So this is going to become a to the m plus n. Okay, that is our product rule for exponents. Let's apply it. Let's go to ornament number 1. How cool are those ornaments, right? Designed them myself, must say. Okay, so we have 3 and 3. Guess what? They're the same base. We're ready to roll. Okay, you have to have the same base, though. If you do not have the same base, then you can't do it in this fashion where you just add the exponents together. Can't do that, okay? But in this case, we can because the bases are the same. What we do is we keep the base the same, 3, and then you just add the exponents, 4 plus 7. So this is going to be equal to 3 to the 11th power. And I'm not going to simplify it from here. I just wanted to show how we can add the exponents and arrive at our answer. This one we probably should. Okay, yeah, just leave it at 3 to 11. If you want to go 3 to 11 power, you're going to get some huge number, but just for now, that's fine. 5 to the third power is the same thing as 5 times, whoops, not 3. Sorry. That's a common mistake that people just do 5 times 3. And this is going to equal 125. 25 times 5, 125. Okay, now we have another one. Are the bases the same? Let's take a gander. 1, 2, 3. All of them are y. That's good to go. That means we can add all the exponents together. What do we get? We keep our base the same, y, and then we add our exponents. Let me turn it to green. 8 plus 2 is 10, plus 3 is 13. Y to the 13th power would be our final answer. Okie doke. Moving on to D. Okay, D, we have some mix. We have some coefficients here, as you can see right there, coefficients. And we also have some y's with exponents. Now, anytime you have coefficients, you're always going to multiply those first together. So we get 5 times 3 is negative 15. Because the bases are the same, we're going to keep it y, and then we're going to add our exponents here and here because the bases are the same, and it's going to be 6. You don't distribute this to the 5. You don't somehow think, oh, this 5 and negative 3 are different. We can't combine them. Okay, coefficients are different. So just keep that in mind. So that's our answer there. I've been highlighting them. I might as well keep highlighting them in blue. All right. Again, let's look at the coefficients here. Let's look at like terms. So we have 7 and 2. So 7 times 2. I'll write this one out this time. Then we have, okay, we have a couple different bases here. We have P, and then we also have, let's go purple. We also have Q. Okay. Let's work on the P first. P, we have a third power there, so we need to keep the base the same. And then we're going to do 3 plus 5. Q, okay, this one doesn't look like it has a power. I'm going to talk about that in just a second. The temptation here is to put it Q2, okay, but that would be wrong. Anytime you just see a variable by itself, there's an implied 1 there. So really this should be 1 plus 2. When we simplify this further, we get 14, P to the 8th power, and then Q to the 3rd power. And that is going to be our final answer. Okay, so we're just using the product rule for exponents right now to make this a little bit easier for us. Let's get into zero exponents. I had a teacher, Mr. Roosh. He actually has a channel for calculus. He's the one that probably explained this in the most understandable way for me in my life. So if you want to check out his videos, make sure you check out Mr. Roosh. Fred Roosh is his name. I think that's his YouTube channel. I'm subscribed to it, so if you want to take a look. But anyway, zero exponents. The way he explained it to me, we're going to choose an easy number here. We have 3. Okay. Oops. I don't know why I changed this to 2. Okay. I'm just going to give you an example with 3. So 3, as we increase the exponent, we're just increasing the number of times we multiply it by itself. Okay. So then we have 3 times 3 times 3 times 3. Okay. We get it. See, this has got a little pyramid going on. So what happens when you get 3 to the 0? It doesn't turn into 0 because that would be 3 times 0, and it can't be the same as that. Okay? So what happens? What happens when you go 3 to the 0? Well, technically, 1 is a factor of all of these also. So we can multiply this by 1. It wouldn't change the value. So as we get to 3 to the 0, we're going to remove a 3, and we're left with just 1. So anytime we have a 0 exponent, anything to the power of 0 equals 1. Whoops, that's kind of a weird way to put it. A to the 0 equals 1. The only exception is A cannot equal 0. So 0 to the 0 power does not equal 1. But actually, there's a discussion on this. I'm not going to write that because there's some people that think that A to the 0 should equal 1 and A 0 to the 0. Did I say A? I meant 0 to the 0 should equal 1. There's some people that think 0 to the 0 equals 0. I'm more aligned with this camp right here. Okay, but I'm not going to write it down as a general rule. It's not going to usually ask you questions like that. But just think a to the 0 power equals 1. Anything to the 0 power equals 1, okay? I'm going to write this like this. Power of 0 equals 1. Okay. So we have 6 to the 0 power. We're going to write 1, okay? It's as simple as that. We have negative 6 to the 0 power. That is 1, okay? It doesn't matter. This whole thing in parentheses is raised to the 0 power, so it's 1. Now, this one's a little different, okay? Because this is going to follow order of operations. The first thing we have to do in order of operations is raise to the 0 power, okay? So we do 6, that's our base, to the 0 power first. So we get, when we do that, we get 1. But then we also have that negative out in front, so it becomes negative 1. This is tricky. This happens with a lot of exponent problems. You're going to have something like negative 2 to the 4th power or negative 3 to the 3rd power. You always have to do the exponents first. So I recommend just like putting your own parentheses in there anytime you see exponents. And then you apply that negative sign at the end. So let me just shrink this. Okay. So this one is going to be, where's my answer? Right here. There's my answer. There's my answer. There's my answer, negative 1. Okay. Now this one, we have like a double take here. We have negative 6 to the 0 power. We know that's equal to 1. But then we have that negative sign out in front, so we get negative 1 again. Okay, this time we have 5 to the 0, that's 1, plus 12 to the 0, that's 1. So that equals 2 when you add those together. Okay, then we have 8 times, this is that one. You don't have to worry about, technically, gal. This is what I was talking about earlier. And I'm hesitant to write this, so I'm just going to erase that. You saw nothing. So then we have 8 times k to the 0 power. And it doesn't even matter what's inside here. It's going to be 1. Okay, so that value of k could be anything, and it's going to be 1. All right. I think I'm going to save negative exponents for another day. This is a whole nother beast. And we have our negative exponent rules. And we'll get to that in part 2 of this video. Hope you enjoyed watching. I look forward to seeing you soon.